Electric potential. Today I will talk about the electric potential energy. Now, electric potential energy of a uniformly charged thin spherical cell, conducting or non-conducting. Consider the cell has a total charge Q. The electric potential energy is equal to the work done in bringing a charge from infinity and put them on the cell. Suppose at any time the charge on the cell is Q, the potential at surface is V equal to Q by 4 pi epsilon naught R. The work done bringing a charge dq from infinity to this cell is dw equal to V into dq. Hence the total work done in assembling the charge equals to W equals to integration 0 to Q dW or integration 0 to Q 1 by 4 pi epsilon naught Q by R dq equals to 1 by 4 pi epsilon naught 0 to Q dq equals to 1 by 4 pi epsilon naught Q square by 2 in the limit 0 to Q equals to Q square by 8 pi epsilon naught R. Thus, potential energy of a spherical cell equals to Q square by 8 pi epsilon naught R. Next, electrical potential energy of a uniformly charged sphere non-conducting. Here the charged sphere is non-conducting, that is, charge is uniformly distributed over the volume. Consider the sphere has a total charge Q uniformly distributed in volume. Hence, volume charge density rho equals to Q by 4 by 3 pi RQ, where R is the radius of the spherical body, or 3Q by 4 RQ. Now the electric potential energy of a sphere is equal to the work done in bringing the charge from infinity to assemble the sphere. Suppose at any time charge is assembled up to radius x. We bring some charge from infinity to increase its radius from x to x plus dx. When the radius of the sphere is x, the charge contained in it is Q equal to 4 by 3 pi xq into rho, or equals to Q by RQ into xq. The potential at the surface is V equal to Q by 4 pi epsilon naught x. The charge needed to increase the radius from x to x plus dx is dq equal to 4 pi x square dx into rho, or equals to 3Q by RQ into x square dx. The work done in bringing the charge dq from infinity to the surface of the sphere of radius x is dw equals to V dq, or 3Q square by 4 epsilon naught R to the power 6 into x to the power 4 dx. Hence, the total work done in assembling the charged a sphere of radius R is W equals to 3Q square by 4 pi epsilon naught R to the power 6 integration 0 to Rx to the power 4 dx, or equals to 3Q square by 20 pi epsilon naught R. Hence, U sphere, that is potential energy, it is also called self energy. So, potential energy of a sphere is 3Q square by 2 pi 20 pi epsilon naught R equals to 3 by 5 1 by 4 pi epsilon naught Q square by R. Next, electric field inside concentric sphere or a spherical charge distribution. This is an insulating charge. There no need to be a insulating charge. Only it need to be that is charge distribution should be in volume. Here three concentric sphere is shown. That is, this is on in the innermost sphere has charge q1, then the charge has minus q2, and the last sphere has charge q3. Then we have to find the electric field intensity at different point due to this sphere, inside point or outside point. The radius of inner sphere is A, the second sphere is B, and the outer sphere is C. So we can use Gauss's law to calculate the electric field at different point. Let's first consider when the distance r is very less, when the distance r is less than a, that is, it is inside the innermost sphere. So we have to draw a Gaussian sphere of radius r, as shown in the figure here, and we know that surface charge density rho will be equal to q by 4 by 3 pi a q, because inner sphere has radius a, so surface charge density will be 4 by 3 pi r q. Now from the Gauss's total flux equal to q enclosed by epsilon naught, if we consider q1 dash is the charge inside this Gaussian surface, then we have to first calculate the q1 dash. So E into 4 pi r square will be equal to q1 dash into rq by aq, because we have q1 dash is equal to rho dv, rho 1 dv, or rho into 4 by 3 pi rq, and we know that value of rho is a by 4 by 3 pi rq, q1 by 4 by 3 pi aq, so 4 by 3 pi aq, so q1 rq by aq, so q1 rq by aq. Hence E will be equal to q1 rq by 4 pi into r square aq equals to 1 by 4 pi epsilon naught q1 into r by aq. This is the value. Now when the point is inside the second sphere and outside the first inner sphere, that is then again we have to draw a, that is the condition is when r is less greater than a and less than b, that is inside the second sphere. And if we consider given the charge on the second sphere is minus q2, so q in will be q2 dash plus q1, where q2 dash is rho 2 into dv plus q1, where dv is the volume of Gaussian surface, so Gaussian sphere, so it will be equal to minus q2 by 4 by 3 pi, and bq minus aq, this is the value of rho 2, and into Gaussian volume 4 by 3 pi rq minus aq, into 4 by 3 pi rq minus aq plus q1, because rho 2 is equal to minus q2 by 4 by 3 pi bq minus aq. Now this solving we will get minus q2, this will cancel out, so rq minus aq divided by bq minus aq plus q1, or equals to q1 minus q2 into rq minus aq by bq minus aq. Now from Gauss's law, E into E equal to q in by epsilon naught, so E equal to 4 pi r square equals to under bracket q1 minus q2 into rq minus aq by bq minus aq into 1 by epsilon naught. So hence electric field E equals to 1 by 4 pi r square epsilon naught under bracket q1 minus q2 into under bracket rq minus aq divided by bq minus aq. This is the electric field inside the when the point is inside the second sphere, that is outside the first inner sphere and inside the second sphere. Next, case 3, when the point is outside the second sphere and inside the last sphere, that is third sphere, so R will be greater than B and less than C. Now here Q3 dash, that is charge enclosed by Q3 dash is the charge enclosed in the sphere of radius RQ minus B, R minus B. So Q dash will be Q3 dash will be rho 3 into dV, and now rho 3 will be Q3 by 4 by 3 pi CQ minus BQ. CQ minus BQ, that is the point is in this spherical cell, solid spherical cell, because here we have considered Gaussian sphere. So we have to first calculate the charge in this solid spherical cell, and which will be given by this formula. So it is Q3 by 4 by 3 pi into CQ minus BQ into 4 by 3 pi. The volume of this spherical solid spherical cell will be 4 by 3 pi RQ minus BQ, or equals to Q3 into RQ minus BQ by CQ minus BQ. So Q enclosed will be Q1, that is charge in this sphere, plus minus Q2 charge in this sphere, plus Q dash charge in this sphere, Q3 dash. So Q1 minus Q2 plus Q3 into RQ minus BQ by CQ minus BQ. So from Gauss's law, EA equals to Q in by epsilon naught into 4E into 4 pi R square under bracket Q1 minus Q2 plus Q3 into RQ minus BQ by CQ minus BQ into 1 by epsilon naught. So finally we get E equal to 1 by 4 pi epsilon naught R under bracket Q1 minus Q2 plus Q3 into RQ minus BQ by CQ minus BQ. Case 4, when R is greater than C, in this case point is outside the all sphere. So we have direct from Gauss's law, E equal to Q in by epsilon naught, or E into 4 pi R square Q1 plus minus Q2 plus Q3 by epsilon naught. So E will be equal to 1 by 4 pi epsilon naught R square into Q1 minus Q2 plus Q3. So this is the different situation for a spherical solid when charge is distributed in the volume.